cubed. Today we will be continuing with the topic of substitution. And we would have done some work on this last class, right? So we know what is a variable, right? And our variables are our letters or symbols, right? And they take or hold the place of a constant, right? And the constant are our numbers, right? So in this question here, they said, let x, the variable x, be equal to 2. Let the variable y be equal to -3, and let the variable z be equal to 4. Now they're asking us to solve this now. X cubed, y cubed, 3, I'll say 2z squared, 4, I'll say xy cubed, right? So I'm going to do the first set and then you guys will jump in. So if I say x cubed, solve x cubed, we know that x is equal to 2. So wherever I see x, I substitute it and put 2 and fill in the rest of the equation. So that's going to be 2 cubed. And we put 2 cubed on our calculator and we will get 8. Now that's the end. We go on to the second one, y cubed. The variable y is equal to -3. So -3 cubed. And if we put -3 in the calculator, -3 cubed, we get -27. Right, so we move on to the other one, 2. Now 2z squared means 2 multiplied by z squared, right? Remember when numbers are next to each other like that, it's the operation of multiplication. So that's going to be 2 multiplied by z, which is 4 squared. Now pay attention, only the z was squared, not the 2. So 2z squared, only the z will be squared. So that's 2 by 16, which is 32. Now if we look at this example, yes?
For the both numbers of both, to be considered squared, they have to be in a bracket.
Correct, like number 4 here. So for this example here, we have brackets and the cube is outside of the brackets. So that means that everything within the bracket is squared. So they are saying x multiplied by y, all cubed. So we open brackets and we put x, which is 2, multiplied by y, which is -3, close back that bracket and we put the cube. So we'll know it's going to be -6 cubed. And now we work out -6 cubed, which is -216. So look at number 3, no brackets. So we attach the square to the last term alone, because that's where it is. Brackets, so we attach the cube to everything within the brackets. So we work out BODMAS, which says work out what's in the brackets first, and then work out the power or the exponent. Right, so that's how we ended up with -213.
So the one number 3. When you have the 2 by 4, if you have the squared outside the bracket, will it make a difference?
No, it wouldn't. Yeah, so you'll see me interchanging between having the squared inside and having the squared outside. There is absolutely no difference. If I put it outside, it will still be associated to the 4 alone, because the 4 is the one in the brackets. Yeah? So let's do some questions now where you all could attempt it. So y squared, z cubed, 6, 3, xy squared, 7 will be 7x cubed, y, and 8 will be x squared y over z. right? So you guys take a minute and do that, do those questions. So we have y is equal to 2, -3. So we have -3 squared multiplied by 4 cubed, right? Which will be -3 squared, which is 9 by 4 cubed. So 9 multiplied by 64, which will give us 64 by 9, 576. Let's do this one now. 3 by x. X has a value of 2 multiplied by y, that has a value of -3, and of course the y alone is squared. So that's 6 by 3, -3 squared is 9, so 9 by 6 is 54, right? Now we have 7 by x, which is 2, 2 cubed by y, which is -3, right? So 7 by 2 cubed is 8 by -3, right? So 7 by 8 by -3 will give us 168, a product of 168, and 2 squared.
Because I just had the line before, so I did this 7 by 8, which is 56, and then I had it by the -3, and then I had the -168.
That's fine. But all of them are multiplying together, so you don't need to break down that line there. So 2 squared by y, which is -3, all over z. Z is equal to 4, so we multiply the top 2 squared, or we get 4 by -3 over 4, which is -12 over 4. And of course, this is an improper fraction, so we simplify that. -12 over 4, that will be -3, all right? Any questions here?
No.
Awesome. So we are going to get into some rules of direct numbers or directed numbers, aka negative and positive numbers, right? So there are different rules for addition and subtraction compared to multiplication and division. The first rule for addition and subtraction of numbers is that when your signs are the same, and when I say sign, I mean positive or negative. So when your numbers have the same sign and they are adding or subtracting, we add them, right? Our rule is to add the two numbers, forget about the sign, add the two numbers, and then our final answer, we put in the same sign that we had. So for example, 4 plus 3.
This is only for subtraction. I mean, addition.
We'll get to there. We'll get to there. So for example, 4 plus 3, they are both the same sign. So we add them and we keep the sign, which is a positive. And now example 20 plus 5, they are both positive. So we add them and we will keep the sign, which is positive 35. Now, if we go into another example that says -4 minus 3. So following up on Joshua's question, we are seeing negative numbers now, well, subtraction signs. So 4 is a negative number and 3 is a negative number because they both have that negative or subtraction sign in front of them, making them negative numbers, right? So 4 is negative, 3 is negative. Therefore, I still have to use my first rule, which says add. So 4 plus 3 is 7, and I keep the sign, so my answer will be -7. If I check out another example here, and I say -20 minus 15, they both have that negative sign in front of them. Therefore, they apply to this rule our signs are the same. So we add them. I know it's going to be kind of crazy in your mind because you're saying what, 20 minus 15, but we have to add them, which will give us 35, and we keep the same sign, which is negative 35. And let's think about the logic behind it. You have money, right? You have money and you get more money. Therefore, your answer will be a greater sum of money. You have no money, so you have to borrow more money. At the end of the day, you will be in a greater set of debt. Yes? Because one is it's increasing in the same quantity. So you have $5 and you just got $15. That means you would now have $20. You don't have $5. So you borrowed $4 from somebody. You borrowed $4. And when that $4 is finished, you borrowed $3 from someone else. At the end of the day, you will be owing $7. Therefore, you are in a negative. Are you guys following the rules of the same signs and how they increase in the same sign?
Yes, I know we probably ain't reached there yet, but a negative is also positive.
That's for multiplication and division. Different rules for addition and subtraction. Yeah. Right. So the second rule of addition and subtraction is that, well, if the first rule is when your signs are the same, then our second rule will be when the signs are different. What do we do, right? So when your signs are different, the rule for that will be to subtract and keep which sign? The sign of the larger number. All right, so let's put this to test and see. So we already know how to do this one. 4 minus 3, but we didn't know the rules behind it though. We subtracted them and we put 1 and we left it as a positive. Why? Because the larger sign was positive. So that's how we ended up with that, a positive. So if it was a flip now and we said, oh, if we say negative 4 plus 3. Now I am like, okay, 4 plus 3 is 7, but no, it is not positive 4, it's negative 4. So when the signs are different, even though I'm seeing an addition sign in the middle of this, I have to forget that and remember my rule that says if the signs are different, when we are adding or subtracting, we have to subtract. So I have to say 4 minus 3, which will give me 1. And therefore, I have to take the sign of my larger number, which is negative. So negative 1. Going into another example, if I have 5 minus 20, now 5 is a positive number, 20 is a negative number. So two different signs we must subtract, which is 20 minus 5, which is 15, and take the sign of the larger number, which is the 20, which is a negative. Last example, we say 41, negative 41, add 21. Again, I am seeing an addition sign in the middle there, but my first number is a negative number, so I cannot add them. My rule says when the signs are different for addition and subtraction, I must subtract. So I have to say 41 minus 21, which is 20, and I keep the sign of the larger number, which is negative 20.
For example, sorry.
Go ahead.
For example, 3, 25 minus 20. Even though the 20 comes after the 5, we still have to do like it was before the 5.
We still have to subtract the two numbers, correct? Yeah. So we take the larger number and we subtract the smaller number, and then we take our sign from the larger number. Nice. So make sure it sinks in. There's only 2 rules for addition and subtraction. Only 2 rules. When the signs are the same, we add, keep the sign. When the signs are different, we subtract and keep the sign of the larger number. So let us get into our
Let's just almost.
So our rules of multiplication and division goes as follows. Multiplication on the left, division is on the right. So we have multiplication and subtraction in one, right? So we have 4 multiplied by x, which is 2, then squared by y, which is -3, minus 3 multiplied by x, which is 2, by z, which is 4. So that will give us 4 by 4. Actually, I could just multiply this whole thing, right? So I could say 4 multiplied by 2 squared multiplied by -3 in my calculator, saving time, right? -48 minus 3 by 2 by 4, that's 6 by 4, which is 24. And just like that, we end up with addition and subtraction rules. That says when the signs are the same, we add and keep the sign. Or I could just take my calculator and press -48, subtract 24, and I will get -72. Right, but it's good for you to know your rules as well. Let's do the second one. 3 open brackets 2 squared by y, which is -3, plus 2 by 2 by only the z squared. So 4 squared, which is, I can put this in the calculator, 3 by 2 squared by -3, 3 by 2 squared by -3, which is -36, plus 2 by 2 by 4 squared, which is 64. And we're back to addition and subtraction, which says when the signs are different, we subtract and keep the sign of the larger number, or we can say -36 and 64 in our calculator, which will give us +28. Any questions?
Yes.
Awesome. Let us to right, so we would have easily combined multiplication and addition and learned all the 4 rules in one, right? Let me just get one more question for you guys to do before we move on. 1 or 2. So A is equal to 4, B is equal to -3, and C is equal to 2. I want you to work for me the value of A squared, open brackets, 2B minus C. Hard, right? So we follow the flow, just like all other questions, which will say A is equal to 4, so 4 squared, open brackets, 2 multiplied by B, which is -3, minus C, which is 2. Then we simplify this, right? 1 second. All right, so we say 4 squared, which we could already say 16, open brackets.
Because of brackets, if we follow in but the brackets come with.
It's okay, we could work out the 16 because we're not doing anything else, right? When we work out the brackets, we still have to come and work out the 4 squared, right? So we could do them together. If you understand what I mean, I'll show you after. So 2 by -3 will be -6 minus 2, right? Now we could come now and say, well, work out the brackets, which is -6 minus 2, which will be when the signs are the same, we add and keep the signs, so that's -8. And now we multiply, so 16 by -8 will be -128. Now to answer your question about this, so if I have 4 squared by 2 by -3 minus 2, and I come now and I say 4 squared by -6 minus 2, 4 squared by -8, I'll still have to come and say 16 by -8, right? So it doesn't affect if I do it first or if I do it last in this particular question because there's a flow.
This if I choose to do it like how it was done there. That's how I do it.
That's okay. It's fine. It's fine. But it wouldn't be wrong if you do this, you work out the squared first, because remember, you would still have to go now, work out what's in brackets, and you still have to come back and work out the powers, right? But if your power was tied up in something else, where you actually have to work out the brackets, then you square it. So like this, if it was -6 minus 2 squared plus 3, right? If it was a question like this, we must work out the brackets first, right? Because only when we work out the brackets and we get -8 squared plus 3, then we have to square it, which will be 64 plus 3, yeah? Which will be 67. But when the square was outside, we could have worked it out while we were working in our brackets as well, because only at the end, both of them will have to multiply by each other. Yeah?
So, but mass is only applied.
No. Don't even ask that question. But mass is still being applied, right? We are still, and we still have to work out the brackets, right?
Right, but we didn't do it. We didn't do the brackets before the power.
Because it could
we did the power first.
We could have, no, we did them together.
Oh.
We did them together. The power was just in front, right? So,
okay.
But you see when it's something like this, when you have them joined in one part, you actually have to work out the brackets first, because the square is dependent on the bracket. This one, the square is not dependent on what's in the bracket. So we could have worked out the squared plus work out the brackets at the same time and then multiply them. So no, don't try to say what must can only be used when this and when that and when the other. Yeah?
Yeah.
All right. We could get into another question now. 1 second. So for the addition and subtraction of algebraic terms, understanding what is an algebraic term is key, right? So the algebraic terms are just like the algebraic expressions, right? So the 2x, negative 3xy, 4t, 1a, 1lm, or just a, or just lm. These are called algebraic terms. Now the algebraic terms can be broken up into parts. The variable parts, which are the letters, and the numbers in front of them, which are called the coefficients, right? So the number multiplied by the variable is called the coefficient of the algebraic term. Now, the key thing to know about when we're adding or subtracting algebraic terms is that it's not substitution. So we're not going to give x a value or give y a value and then work it out. We're going to add them just like that. But there's a rule. Of course, mathematics is logic. So there's a rule for everything. The rule, however, for adding them is that they must, so in order to add or subtract algebraic terms, they must be like terms. What do I mean by like terms? What do I mean by like terms? They must have the same variables. And you know, they say, we say in Trinidad, same exact variables. For emphasis, it must have the same exact variable, nothing different, right? So A, B is the same variable as AB. It could also be written as BA, but we try to keep it in alphabetical order, right? Same variable. So 2AB, 1AB, negative 3BA, all of these are same variables. Now, if I have x squared, y squared, xy squared, these are different variables. If I have
it's like the same as you can't compare apples and oranges or something like that.
Yes. So we can't add apples and oranges. Like if you go to a fruit vendor and you say, well, can I have half of an apple and half of a banana? Like that's not a thing. And you wouldn't get a banana apple, right? So you can't add or subtract different variables or different terms or unlike terms. So you could add 1x to 2x and subtract 3x. Yeah, we could do that because they are same variables.
There's the one with the x squared and y squared. And those the same variable because it's just itself multiplying by itself?
No, we are not doing multiplication, we are doing addition. So even though they are multiplying by each other, they are not exactly the same. One of the variable is x squared, one of the variable is y squared, and one of the variable is xy squared. So this comes like it's an apple, this is a banana, and this is a grafted fruit. That looking like them, but it is not them. Yeah? So there are actually three different terms on the board here. An x squared, a y squared, and an xy squared. Yeah?
You're doing as if there's a plus sign between the x squared and y squared and then equal.
No, not right now. I'm just showing you that they are different variables. We're not adding or subtracting or anything as yet. I'm just showing you that this is one term, a second term, and a third term, and these are same variables. AB, AB, AB. But this is x squared, y squared, xy squared, different variables. This is a x, this is a x, this is a x, same variables. Now, if I say xy squared 2xy squared negative 5xy squared, that they must match exactly. Xy squared, xy squared, xy squared, same variable. Yeah? Yes?
Yes.
So, example, let's see how they work out when we add them up. So if I have x
And then
plus,
I didn't take that.
just now, let me just write 7x plus 12x. Sure. All right, so we have an example here. We are going to add. And when you see a question like this, they'll tell you to simplify the following. So first thing I need to watch is, are my variables the same? X, and x, therefore, they are the same. What's the coefficient on the first x? This one here. 1. So you can put that in there. And we know that when we're going to simplify, what we're going to do is we're going to add the coefficients. So we're adding the coefficients. And we're keeping our variable the same. Keep the same variable, right? Don't change anything. So it's going to be 1, add 7, add 12x. So that will be 1 plus 7 plus 12, that's 20x. So I could just say 1 plus 7 plus 12 is 20x. And that's how simple it is when it comes to adding like variables, but adding and subtracting, right? What about if I say 9x minus 5x? Same variables. So I say 9 minus 5x, which is 4x. Again, we're just adding or subtracting the coefficients and putting back the same variable. 12x. So it's just like regular adding numbers, but there's a variable in it, right? So 12 add 5 minus 9 brackets x. So that will be 12 plus 5 is 17. 17 minus 9 is, how much is that? 17 minus 9. What do you think? How to work that out? How would we go about working this out? Regular addition and subtraction, right? So 8x, we say 12 plus 5 is 17. 17 minus 9 is 8. And we put back our same variable. Example. If I have negative 15x minus 8x minus x. Again, brackets, I put my negative 15. So anytime you see a sign in front of that number is associated with the sign, right? So negative 15 minus 8, this will be minus 1. Yeah, we have to put in that 1 even though it's not there, right? So minus 1x. When the signs are the same, we add and we keep the sign. So 15 add 8 is 23, 23 add 1 is 24, negative 24.
Let's do the minus,
X.
I mean 8. Because of our minus sign is considered
Because,
negative.
yeah, because there's a minus sign in front of it, the minus sign is associated with the negative, with the 8, so it comes like negative 8. What about 3x minus 7x? Again, 3 minus 7x, which will tell us negative 4x. Example, 15x minus 9x plus x. 15 minus 9 plus 1 x, which will be 15 minus 9 is 6. 6 plus 1 is 7x. How y'all doing? Not too shabby, right? Yeah?
Yes, miss.
So I'm just going to go on to this last step, giving you all 2 seconds. And this last step I want you all to do before we, because really and truly, this is addition and subtraction of algebra. Yeah, I know you can't believe that it's so easy, right? So the last thing we'll do is when they start to mix variables. So simplify again. We now have a question of simplifying that has a 9x plus a 3y minus a 5z plus an 8y minus a 4x plus a 12z. So first of all, we know that they are not like variables. So what we have to do now is group our like variables. So there's a 9x, search through, search through, search through, and there's a negative 4x. So we write this first, 9x minus 4x. So we're grouping our like variables, right? So take your time, start from the top and you go. There's a positive 3y, there's a positive 8y, so we write that. Positive 3y, positive 8y. There's a negative 5c, and there's a positive 12c, so we write that. Negative 5c, positive 12c. So I hope that you all are paying attention and you all see that I am moving each number with the sign associated with it. So positive 9, negative 4 is going to come here, not just positive 4, but the negative 4. Positive 3, positive 8. Negative 5z, positive 12z. So we move the number with the sign that is associated with it. And now we add up our stuff in parts. So we say we could work out all the x's together, which is, it comes like we took apples from different places and we're counting out how many apples we have in total. So 9 minus 4 will be 5x. Now we finish with the x's, we come, so be mindful that this is not different equations we're doing in one. Our answer is still as one answer, so we're keeping them close. I don't want to see answer here and far, right? So now we're going to say positive 3 add 8, which is positive 11y. And then we're going to say negative 5, remember, keep the sign that's associated, plus 12. Negative 5 plus 12 is positive 7z. So what you could do is use your calculator, guide you, or write in your steps accordingly. Yeah.
What you just call the entire thing, so the coefficient plus the variable plus the sign, when you move that whole thing, is there one term to describe all of that?
Grouping.
No. to describe the coefficient and the variable plus the sign? Is there one way to describe all those together?
It's an algebraic expression on algebraic equation, algebraic expressions. Yeah, so we're adding or subtracting algebraic terms. Yes.
Okay.
Yeah, that answers your question, Joshua.
Kind of, yeah.
All right. All right, so we're just adding up our algebraic terms, simplifying everything, yeah? So the question will tell you to simplify it. Right, so let's do one more question. Any questions before we do the second question?
Or we have plus 7z.
Yeah. Keynotes here, this is our answer, this is our final line because we have different terms now, right? A x, a y, and a z, and we cannot add them up or we cannot subtract them, so we have to stop there. You had a question, Joshua?
I was asking how come we get plus 7, but I don't realize a negative and a positive, which
Don't
have
say
different
that.
signs. We subtract and keep the sign of the larger number.
Larger number, yes, yes. I like how you stopped while you were in the sentence. So let's do a decimal one. 1.5 p squared q minus 0.3 p q cubed plus 4.1 p squared q plus 5.0 p q q. So we see that they are different variables, so we have to group them. The first variable is p squared q, so we go through as a find the comma, we look for p squared q again, and we found it here, right? So that's what we're going to write first. 1.5 p squared q, add 4.1 p squared q, and then we go on to the others. Negative 0.3 pq cubed, and our last term is pq cubed as well. So we remember the negative is associated with the 0.3. So negative 0.3 pq cubed, add 5.0 pq cubed, and we work it out. 1.5 add 4.1 will just be 5.6. Put back the same variable, p squared q, and then we have negative, don't forget it's a negative, so we put this in our calculator. If we want negative 0.3, add 5, that will give us positive, so we put our answer right here, positive. So if it's just a 4.7, it's positive, so you have to put that positive sign, right? So positive, add 4.7 p q cubed. Any questions? So I don't want to see this. I don't want to see this as your answer. This will be wrong, and I will put it wrong. Right? So if your answer is positive in the calculator, you put positive. If your answer is negative in the calculator, you put your negative sign or your subtraction sign in the middle of both of them. And it must look like one full answer when you finish, not two broken up, one on the left, one straight on the right, etc. Yes? Any questions?